Hello and welcome to another video from the only channel that you need to not only survive the current apocalypse, but actually enjoy it. And today's video is going to be called Have Your Cake and Eat It Too. And it's going to be about the relationship between the first law of thermodynamics and the Ice Age. I oftentimes will say that you cannot have an Ice Age and also have a first law of thermodynamics. And it seems like every time I say it in front of a camera, I get a whole bunch of comments back about how the Ice Age did not occur in a closed system. So we're going to address that. And for anybody that wants to make that comment again in a future video, I will simply send them this answer video, this response video. First off, the first law of thermodynamics originally was started off by being the law of conservation of matter. And this law was discovered by some physicist hundreds of years ago, maybe 1,000 years ago. And it simply states that you can take a brick from this table, put it on that table, but you cannot make this brick stop existing. You can take that same brick, cut it in half, put half on that table, half on this table, but you cannot make that brick stop existing. You can crush both halves of the brick into a fine powder, but you cannot make the matter that's in that brick stop existing. In other words, if you've got 1 pound of brick, you'll end up with 1 pound of dust. As time went on and we started to move into the atomic age, it was determined that you could actually convert some matter into energy, at which time the name of the law was changed from the law of conservation of matter to the law of conservation of matter and energy. And of course everybody in every field of scientific study wants to make this law their own law, so eventually, in order to apply these principles to systems involving temperature and pressure, they put their own name on it. They call it the first law of thermodynamics, which is basically still just the law of conservation of matter. Now, every time I say that you cannot have an ice age and have a first law of thermodynamics, I am told that since the ice age did not occur in a closed system, that the first law of thermodynamics does not apply. Okay, I've been to refrigeration school, and I was also in nuclear power school when I was in the Navy. And the first day of school, in both of those classes, we were taught the first law of thermodynamics. So let's look at refrigeration and nuclear power and see if those systems are closed systems. And we'll only have to really examine one. We'll go ahead and stick with refrigeration because I got a nice little example to give you. On my porch is a refrigerator for my house. And it's probably 92 degrees right now. I promise you my refrigerator will not get down to the same temperature that your refrigerator will get to in your air-conditioned house, because that's not a closed system. There are outside influences. Because you cannot take cold and make it stop being cold, or hot and make it stop being hot. All you can do is take heat energy and move it from point A to point B, just like we moved that brick. So in your refrigerator, the things that you put in there that are hot will get cold because the heat is being pumped out of the refrigerator and out the back. You can put your hand behind your refrigerator and feel hot air coming out of there. That's the heat being moved from inside your refrigerator to the outside atmosphere. Now, is that a closed system? No, obviously not. So let's take it a next step. Let's put that refrigerator in a super insulated room. So now inside that room, is that room a closed system? You've got the cold air inside of the fridge that's caused by moving the heat out, and the heat is coming out into this sealed room. No, still not a closed system, because the refrigerator's got to be plugged into an outlet in order to get electricity to run the refrigerator. So here's what we'll do. We'll take that refrigerator and put a generator next to it. Is it now a closed system? Because your generator is right there producing power for the refrigerator, and the refrigerator is making the cold air, or the hot air inside the refrigerator, go out into the room with the generator. No, it still isn't, because you have to have an energy source for the generator itself. The fuel has to be brought in. It's not a closed system. If there is one single thing in the world that any human will ever come into contact that could really actually be called a closed system, the closest thing I can think of would be our solar system. Our solar system exists in an almost endless vacuum in every direction. Very little comes in that could have any effect on the temperature of the Earth, and very little goes out other than what goes out normally. The sun Where it is exactly where it's always been. Now, I can't say that for a fact because I have not been watching the sun for all eternity. But our scientific community has had extremely accurate instruments for measuring the distance of the sun, the temperature of the sun, the size of the sun, the size of the earth, the spin of the earth, the spin of the moon, the lunations of the moon. All of these things have been measured for well over 100 years. And thus far, the sun's rotation, or the earth's rotation, has not changed by so much as 1 second in the 100 years that we've been measuring it. The size of the sun, the size of the earth, all of these factors are almost exactly identical to the day that they first started measuring. And when I say almost, what I mean is that even though our earlier instruments weren't quite as reliable, they measured things maybe a second or two off in one direction or the other. Temperature of 1/100th of a degree off in one direction or other. And that could be attributed to the fact that we have a little bit more accurate instruments now. So basically, the energy coming from the sun is exactly the same as it's been for the last 100 years, and there's really no other energy coming to us other than background radiation, which is negligible. So, in order for our planet to freeze, which is basically the Ice Age says that the vast majority of our planet froze, we have to have something that we can prove happened to cause that. In other words, there has to be a record somewhere of a planet just wandering over between the Earth and the sun and parking itself there for a long time, extended period of time, in order to block out the energy coming from the sun. There's absolutely nothing to indicate that that's ever happened. In fact, there's absolutely nothing to indicate that anything has ever happened that could hamper the sun's ability to get energy to the Earth. Now, scientists that measure the polar ice caps say that they're growing and they say that they're shrinking, but really we've done enough stuff down here to the Earth to cause that. Just cutting down all of the planet's trees would have some kind of effect on the size of the polar ice caps. And in fact, if whatever the polar ice caps were 100 years ago, if we just put back all the trees we've cut down and stop pumping things into the air, I'm certain that they would go back to that exact same size. So yes, the Ice Age does have to abide by the first law of thermodynamics, the law of conservation of matter and energy, and the law of conservation of matter. There's no way around it. Just as an interesting side note, this Ice Age was supposed to have killed off populations of human beings. Now, every culture on the planet, Native American culture, Chinese culture, Holy Land culture, has got some kind of story, a myth, about a flood, global deluge. Every culture on the earth has got some kind of a myth about a global deluge. Whether that happened or not, if an ice age happened, shouldn't we have cultures around the globe with a story of a global ice age? If you don't want to survive, don't listen to me.